next is function of insertion. How to add element in queue. First case, we will check whether the queue is full or not. How to check whether the queue is full or not? If real is equal to max minus 1, printf queue is full. We can't add an element in this queue. Queue overflows. Next, if there is a space at the rear end, then we simply write rear plus plus and add item at the rear end of this queue. This is the second case. And third one is if front is equal to minus 1. Front is equal to minus 1 means queue is empty. And front is equal to minus 1 means queue is empty. And we want to add an element in the queue. Then what will we do? We will set front is equal to 0. Then add item at the rear of the queue. Now these are the cases of insertion. First case, we will do 10, 20, 30, 40. 0, 1, 2, 3. Max is 4. Rear is equal to max minus 1, 4 minus 1, that is 3. This means first case, this is the first case. This means queue is full. We can't add an element in the queue. Second case is if there is a space, at the rear end, like this, 0, 1, 2. In this case, initially rear is 2. We want to add one more element. Then what will we do? Rear plus plus. Increment rear by 1. Once you increment rear by 1, now add any element at a rear. Now our rear is 3. Once we increment rear by 1, now add item at the rear end at A3. A0, A1, A2, A3. This is the second case. And third case is, this is the third case, if front is equal to minus 1. Queue is empty. There is nothing. Queue is empty. Queue front is equal to minus 1 indicates queue is empty. There is no element. Then we will set front is equal to 0. Or you can also write or front plus plus. When you write front plus plus, initially it was minus 1. Minus 1 plus 1, it will become 0. Now set front is equal to 0. Now this is front. And this is also a rear. Right, add item at the rear end of the queue. Add any item at the rear end. Because there is no element, initially there is no element in the queue. The element you will add, that will become the front or rear. Because there is only one element. Initially it was empty. When you add element in this queue, this is also a front end, this is also rear end. Because there is only one element. Again, when will you add next element? Now rear becomes, the rear is incremented by 1. Now rear becomes 1, add item, add 25 at the rear end at 1 position. Now front is 0 and rear is 1. This is how to add an element in linear queue. There are 3 cases. One is, first you will check whether the queue is full or not. If queue is full, simple write printf queue is full. How to check? If rear is equal to max minus 1. Next case, if there is a space at the rear end, like this. In this case, there is a space at the rear end. Simple, add increment rear by 1 and add item add any element at the rear end, at the A3 position. And third case, if Q is empty, there is no element, then set how to check whether the Q is empty or not. If front is equal to -1, this means Q is empty. Set front is equal to 0 or front plus plus. Front is 0, we have set. Rear is also 0. Add item at A front or A rear, because we have only one element. Now we have added. If you want to add another element, add 20. First increment rear by 1, then add element. We have incremented rear by 1. Rear becomes 1. Now add 20 at A1. This is the insertion operation, insertion algorithm. This topic is deletion of an element from a queue. How to delete an element? Again, there are three cases. First of all, we have to check whether the queue is empty or not. If the queue is empty, then there is nothing to delete. We can't delete an element. This is the condition to check if front is equal to -1, printf queue is empty. This is the first case. And second case is if there is only one element. Suppose there is only one element, then front, rear both are 0. Because there is one element, front is equal to 0, rear is equal to 0, and at front 0, rear 0, 10 is stored. When we remove this element from this queue, then set front, rear to -1. How to remove? Assign A front to any temporary variable. Now we have assigned A front, element at A front is 10. We have assigned to any temporary variable. Data part, we have taken variable data, that is of type integer. We have assigned A front to data part, data variable. Data is equal to A front. Then we have assigned 10 to data. And front is equal to -1. We have said front is equal to rear is equal to -1. This is the case. If front is equal to rear, both are equal, then there is only one element. And extract that one element. If you want to print in the main function, we have assigned, then set front rear to -1. And in third case, third is a simple case like this. If there are elements in the queue, delete the front element. When we delete the front element, front is incremented by 1. This is the case. Now front becomes, initially it was 0. When we delete this one, we have already assigned to data part, assign this one. When we remove this one, front is incremented by 1. Now front becomes 1. Now there are three cases. First case, we have to check whether the queue is empty or not. If the queue is empty, there is nothing to delete. Simple write, queue is empty. This is the condition. If front is equal to -1. And you can also do one thing. You can also, if you don't want to write this thing, you have to write data is equal to A front in if part, as well as data is equal to A front in else part. Therefore, we have written only once. If you don't want to write again and again in if and else, we have write once. We have assigned A front to data part. Now this is the first condition we have checked. Second condition is if there is only one element. If there is only one element, front 0, rear 0. Assign that one element to any temporary variable. We have assigned and set front or rear is equal to -1. This is front is equal to rear is equal to -1. This is the second part. And third condition is this one. If there are more than one element, delete the first one, because deletion always takes place from the front end. Delete the first part. When we delete the first part, front is incremented by 1. Now front becomes 1. These are the 3 conditions we have to check. This is how to delete an element from the queue, from the linear queue. So this is the complete program of linear queue. We have already done insertion function, deletion function, how to add an element in linear queue and how to delete an element from a linear queue. We have already done that. Now this is just a how to call function. Now these are the declarations. We have defined hash define max 10, and these are the declaration, array and element you want to add. Main function. In place of 10 we can also write max, because this is the reprocessor. Wherever it sees max, it replaces max with 10. Initially queue is empty, front is equal to -1, rear is equal to -1. Queue is empty. There is no element in the queue. We have defined one, declare one variable I. Add queue functions are invoked. We have done add queue function. These functions are invoked. Control will go to that function. Then I is equal to del q a. Del q functions are invoked. Printf item deleted is %t, I. We have done this in previous lecture. I is equal to del q a. That del q function, control will go to that del q function, delete function, and whatever the element we have deleted, it is stored in I. Then printf item deleted is %t, I. It will print the deleted item. This is the complete program of linear queue, insertion and deletion.